Hi, this is Dela Bolina. This is the motion simulation tutorial with a simple cylinder and crank. This is Spring 24 CCET 3690. Some objectives for this tutorial is to create a basic assembly with a cylinder, crank, and base, import assembly into NX and activate the motion simulation workbench, create motion bodies, otherwise known as links, for joints to be connected to, create joints, constraints to the environment, create a solution and solve, and play the simulation we created. My contents are importing an assembly, motion bodies, joint dialog box, which will go over the fixed, slider, cylindrical, and driver joints, solution dialog box, and the animation playback, which all my page numbers are listed here. Task 1 would be importing the assembly. After creating a simple assembly, you'll want to open up NX, go to File, Open, then search for the assembly you've created, and select the assembly and press OK. So I'll show you guys how to do that. So I will go to File, Open. I will go find the assembly that I have created, and I want to make sure that it's a part file so I can grab it. And for video references, I'm just showing you this, but I already have my assembly open. Next, I'll want to make sure that I'm in the advanced role. I'll go to Roles, Content, and Role Advanced, as shown below here. So I will go here to the left to Roles, Content, and I will be in the advanced role. So I'll press Role Advanced, and I'll just select OK after this box shows up, and normally it would change and give me more options up here. Once that's completed, I want to activate the motion simulation workbench. So I'm going to do that by heading over to Applications, Motion, and then New Simulation. So I will go here. Up to Application, and then I will go to Motion. I'll click here, and generally, once I click here, it will say New Simulation, but since I'm already in my simulation, it will not show up. But there are other ways to do it. You could also click your assembly, right-click, and press New Simulation. Once you click New Simulation, this environment box will open up. You want to enable component-based simulation, and then press OK. Task 1 is finished. Your motion simulation environment is activated, and then you want to create your motion bodies for task 2. So underneath the Home tab and underneath above Mechanism, select Motion Body. And in the Motion Body dialog box, you'll select an object in your assembly, and you'll want to do this for every part in your assembly. Note that I have 5 components in my assembly, so I will have 5 motion bodies. So up here, you'll select Motion Body, and you will select every single part in your assembly. So since I already have my motion bodies created, I'll show you. For the first motion body, I have this crank handle selected. Once it's selected, I just press OK. I have 5 motion bodies here. As you can see, they're all selected. And once that is complete, you have finished the motion body task. And you'll move on to task 3, which is the joints, which is the longer part of this tutorial. So for joint 1, to create a joint, you're going to press Joint in the left-hand corner right below Motion Bodies in the Home tab in Mechanism. For our first joint, in the dialog box, we will create a fixed joint. We'll use the drop-down list in Type and select Fixed. We'll select our base as the motion body. Note that all components are motion bodies at this point. Specify our vector in the perpendicular motion and press OK. So as you can see here, I already have my joints, but for video reference, I will go into it. Once my joint dialog box is open, as you can see, I select my motion body, which is my base, specifying my origin, which doesn't necessarily matter on this part, specifying my vector, which is always perpendicular to the base, and I will click OK. Joint 1 is complete, and we'll move on to joint 2. I'll be pressing joint again in the left-hand corner. I'll use the drop-down list and Type and select Slider. I'll select my cylinder as my motion body, specify my origin in the center of my cylinder, specify my vector in the perpendicular direction, and lastly, under base, select my base as my motion body and click OK. So for joint 2, as you can see here, this is my selected motion body. I went to the type selection box or drop down list, selected slider. My origin is the center of my cylinder, and then my vector is always perpendicular of my origin. And for my base here that I want it to be a slider joint with is going to be this base right here I selected earlier. I'm going to click OK, and my second joint is created. Next, we're going to go on to joint 3. We're going to go to the left-hand corner again in NX, press that joint button. We're going to use the drop-down list and type, select revolt. We're going to select our crank as our motion body, specify our origin in the center of the crank hole, center hole of your crank, and then specify your vector in the perpendicular direction. Lastly, our base that we're going to select is our pin motion body, and we're going to click OK. So for joint number 3, I'm going to open that up. We're going to go into the type drop-down list and select revolt. We have revolute. We have the select motion body, which would be the crank, specifying my origin at the top center hole. This is important. I can do this by using this drop-down, clicking the arc ellipse sphere in center. If I click the edge, it'll snap to the center. Specify my vector perpendicular to my origin, and my base is my pin motion body. And I'm going to press OK. That is the third joint. That is finished. And I'm going to move on to the fourth joint. I'm going to select the joint button again. I'm going to the type drop-down list and selecting revolute, and selecting my crank as my motion body, specifying my origin in the bottom center, this is important, hole of my crank, and specifying my vector in the perpendicular direction. Lastly, under base, I'm selecting my handle/crank attachment motion body, and I'm clicking OK. So this is number 4. Once again, I'm going to my type drop-down list, revolt or revolute, and then selecting my motion body, my action motion body. Action is most of the time what is moving in the motion simulation. Is my crank, specifying my origin at the bottom. Once again, I'm snapping to the middle of this bottom hole in the crank, specifying my vector perpendicular to the vector or origin, and then for my base, I'm selecting my motion body as my handle crank attachment. Then I'm selecting OK, and that is it for joint 4. Moving on to joint 5, I'm creating another joint by going to the left-hand corner, pressing joint using the drop-down list in type, and selecting revolute again. Select your handle crank attachment as your motion body, specifying my origin at the top circle of my handle crank, and I'll explain why, specifying my vector in the perpendicular direction. Know that this will also be our driver joint, and I will explain to you why. So after we finish the definition, we're going to go to the driver tab. Under rotation, we're going to use the drop-down list to select polynomial, set our velocity to 360 degrees per second. So I'll go ahead and show you that with joint 5. So here, we're selecting our motion body as just this handle crank on its own, specifying this origin at the top middle because we want it to rotate around this point right here, specifying my vector perpendicular as always, and we don't need a base because this is going to be our driver. I'm using this drop-down box in rotation to select polynomial. And then my velocity is going to be 360 degrees per second, like I said, and I'm pressing OK. And that's going to be it for joint 5. Moving on to joint 6. We're going to the upper left-hand corner to select joint using the drop-down list type and selecting the cylindrical. Select my cylinder as our motion body, specifying our origin at the center of our pin, specifying our vector in the perpendicular direction, and lastly our base is going to be our pin motion body, and we're clicking OK. So for joint number 6, we're going to the type box, going to cylindrical, and this will kind of give us a concentric look for this joint. For our action motion body, we select the cylinder. Our origin is going to be, instead of the top cylinder, it's going to be this hole right here, so we can get this concentric joint between the pin and the cylinder. Specifying the vector is going to be always perpendicular. Our base is going to be the pin, and we're selecting OK. And then next, joint 7, we're creating a joint, same way as always. Use the drop-down list and type and select the fixed option, selecting our cylinder as our motion body, specifying our origin as the pin, specifying our vector in the perpendicular direction, and lastly the base is the pin, and we're selecting OK. So this is sort of like the last one, except we're just making it fixed so it stays with each other when it's moving. So drop-down list, we're going to fix our motion body is going to be this one that we want moving, the action one. Specifying our origin in the middle of this hole, this pin as well. Our vector is going to be perpendicular, as always. And then our motion body is going to be this pin right here for the base. We're selecting OK. That's it for joint 7. And lastly, joint 8. Same way we're creating the joint, the upper left-hand corner, press that joint button. Use the drop-down list. We're going to go type and select cylindrical. Select your crank as your motion body, specifying our origin at the center of the pin, specifying our vector in the perpendicular direction, and lastly, under base, selecting our pin motion body, and clicking OK. So for joint 8, we're going to get that cylindrical sort of concentric constraint between these two. So our motion body is going to be this crank. Don't forget to select cylindrical, specifying our origin at the middle of this pin and crank, specifying the vector perpendicular, and our base is going to be our pin once again. The pin is what is holding all this together pretty much. I'm going to select OK, and that will be it for the joints. So once my joints are complete, I can move on to task 4, which is solution and solving. So I'm going to go to the solution button in the top left-hand corner, which would be right here. It looks like that. An information dialog box will pop up, and to be sure that your solution is set to dynamic analysis. Input 3 into the solution and time box, and then click OK. So I'm going to go in. I already have solutions here, but for video reference, I will do it again. So I'm here. I am clicking solution. I'm going to get dynamic analysis. I'm going to set this to 3. 3 is my preference, just how long I want my simulation to run, and you can choose whatever you like. And then I'm going to hit OK, but I'm going to exit out since I already have a simulation done. And then once that is done, we can go to solve. So we'll hit solve in the top left-hand corner, which is right next to solution. An information dialog box will pop up. Exit that dialog box once the information is done processing. So it's going to look sort of like this. I'm going to press my X once it's done processing, and it should be good to go. But before moving on to the next task, I need to make sure I look in my motion navigator to be sure that my solution is active. So I'm going to go to solve. It's going to take a second to load. And then once it is all processed and through, I'm going to click the X. And once I got that all done, I'm going to make sure that my solution is active. Now that I know it's active, I can look at the results. So to do that, I'm going to move on to task 5, which is playing the simulation. To play your simulation, you go to the results tab above animation player, select play. So I'll go to results, I'll press play, and above animation player, select move if you would like to control your simulation and when your simulation is played. So I can use this move animation tab to move back and forth. So let's see. We're going to go over to results. I'm going to press play. It's going to play my simulation. It's looking pretty good. So I'm going to head on to Move just to show you guys how you can play it back, see if you like it, slow it down, speed it up. And then once that is all done, you want to make sure you save your simulation as a sim file, and then motion simulation would be complete. Thank you for listening to the motion simulation tutorial, and that'll be all. Thank you.